Let's play a couple of games. The last couple of problems throughout your homework will be this style, so let's go. Here's a question, and I actually, I believe I put this problem right here on a test last semester before we went into quarantine and all that stuff. And I stumped a lot of people, and I was surprised by it. So let's make sure we don't get stumped. All right, cool. So really all we're trying to do is asking us to find the angle. What's the angle? Because this is how this works. We're trying to learn what the heck's all this stuff saying. Sine of what angle equals a half? And it's asking us to find it in degrees and in radians without using a calculator. Well, if you don't know those special values for those special angles, we're going to have a real hard time. And this is the sort of games that all of us math teachers and physics teachers, we just require, a little bit. I mean, I don't know about all the physics teachers, but some. So let's just look aside. What we need to know is this little table. I make this table. You don't have to use this, but it sure helps us out a lot. What are we looking for? Sine of theta is equal to a half. So we're looking for sine of theta is equal to a half. So we just want to know what angle gives the ratio of 1/2 for sine. So let's start looking. We're like 0, 1/2. Oh, 1/2. It's right there. Well, what angle makes that true? Oh, 30 degrees. Because remember, we proved that little triangle. Remember this triangle? Do you remember this thing? Like a 60, 30, 90 triangle. So this one's √3, this one's 1, this one's 2. So sine of 30, the opposite 1/2, or memorize the table. I don't know. So we look at this, and this is just we call a state the answer. You're just supposed to know. You're like, hey, 30 degrees or pi/6. Those are the same things. We go back to our problem. We're like, well, theta is equal to 30 degrees. But since the question asks for it in radians as well, we're like, well, shit. We can also say theta is equal to pi/6 because those are the same things. And if you don't remember how to get there, you just do the 180/pi if you want to go and convert it. And then once everything cleans up, you get down to your pi/6. But hopefully you don't have to do that with the common angles, like a 30, a 45, and a 60. Get those things down. Make sure you got them. It'll go a long way. All right, now number 2. This one's a little trickier. Now, I advise if you ever asked to find an angle like this, screw secant. Like, it's nice and all, but no cotangents, no secants, no cosecants. Change everything into sine and cosine if you can. If it's a tangent, no big deal. We'll be fine. But isn't secant equal to 1/cosine? Or, you know what? Let's not write it like that and confuse ourselves. Let's do it this way. Because it's true. It is true. Secant of theta is equal to 1/cosine. That is a true statement, but wait a second. Can't we just flip this thing over and call it cosine? Can't we just play that game and go, oh, this is 1/√2? Right, isn't that how we would have solved it? Remember when we're doing we find all of our trigonometric identities? They're just reciprocals of each other, which means flip that shit over. Which means flip it over. So we get that for free just by knowing that identity. And that's what this is saying. Strangely enough, that's what that's saying. Secant is equal to 1/cosine, which means the 1/cosine means flip it over to its reciprocal. Yeah, buddy. All right, so now we're like, okay, cosine of theta, 1/√2, and you're like, cosine, where are we going? Like 1, nope, that's not it. That's not it. That's not, where is it? It doesn't match. But if you notice, every single one of these has a denominator of 2, except for the 1 and the 0, right? So why don't you get a denominator of 2? So let's go back to this and let's change it. Let's rationalize this denominator by √2/√2. So 1 times √2 is √2, and √2 times √2 is 2. Oh, shit, there it is. We found it. It was just kind of disguised. So we're like, okay, well, what angle does that come with? And we go, oh, there it is, 45 or pi/4. So we can find our angle and say theta is equal to 45 degrees, right? Because it went along with this one here. Or we could say theta is equal to pi over 4. And that's just getting us to think in reverse a little bit. Just wanted to show you this table, that there's some value to knowing this stuff. It can also give you tangent, because isn't sine divided by cosine equal to tangent? So what's 0 divided by 1? 0. What's 1 divided by root 3? 1 divided by root 3. And if you rationalize this, this is root 3 over 3. Same thing divided by the same thing is 1. Root 3 divided by 1 is root 3. And 1 divided by nothing? Well, that's undefined. You're not allowed to divide by 0. How dare you? So there's a little table. I don't know. Maybe take it or leave it, but it's got all the values in there and all the important stuff. And if you knew all of these values right here, these same, I think it's a repeat of the same like 4 numbers with just roots on them, I think you'd be unstoppable. I don't know. No, moving on. I don't want to waste your time. So that's how we play that game. We're just trying to find the angles, because the theta is the angle. The outside just represents the ratio, right? The 1 over the 2. That triangle that we have with a 1 over the 2, then this must be root 3. If that angle is coming out, it's just saying our ratio that our opposite is just half as big as our hypotenuse. Okay. Moving on, next game. This was also another problem I put on our first test last semester, and again found some big struggles. So you got some homework on this, and I will do one. So I'm doing one very, very similar to your homework problem. Okay. So it's asking us to find the exact values of x and y. And many of us are going to want to look in here, and it's not a bad idea to think x squared plus y squared is, right? A squared plus b squared equals c squared. But you're going to have a hard time trying to solve for x in terms of y. I mean, that's the only way you're going to be able to do it. You're not going to be able to get a value out of it, so you feel like you're kind of stuck. But the piece of information we're not using would be, what about that angle? Haven't we been talking about this stuff? There's a 60, there's not, what's the two trig functions? What are we playing around with? So the two trig functions, we got a sine. So what's sine of 60? Let's try that. Let's look at that. Just because the angle's there, like, what the hell? Just see what happens. What would it be? What would it be? This would be equal to, so the opposite is y, and the hypotenuse is 16. So y over 16. Oh, wait a second. Isn't sine of 60 just a number? I'm pretty sure sine of 60 is just a number. What's sine of 60? Sine, sine of 60 is root 3 over 2. Sine of 60 is root 3 over 2. Let me write this aside. Sine of 60 just equals the square root of 3 over 2. And since I'm here, I might as well write down that cosine of 60 is equal to 1/2. Those numbers I was telling you, you should get those things down. They're going to be helpful. Because when we're talking about an exact value, you try and punch that shit in your calculator and just give me a rounded ass answer, you're not going to get credit for that. It needs to be exact, which means we need these roots, like that root 3. And maybe you have a calculator that hooks you up with an exact answer. And that's dope. But we must make sure that we're giving an exact answer. This is not a physics class. This is not a chem class where you round. This is a math class. So we want exact as much as we can. Okay. So we go back to this. We're like, all right, we got to mess with you. Well, let's multiply the 16 over real quick. Let's just get it away from the variable we want. And now we have that this is 16 times sine of 60 is equal to that y value we've been looking for. We got it isolated. Well, let's replace in. Instead of writing in sine of 60, let's write in root 3 over 2. And that's equal to y. We'll clean it up. We know how to deal with fractions, don't we? Half of 16 is 8. So it looks like y is going to equal 8 times root 3. And we found y. Now at this point, if you wanted to, you could just plug it right back into here and you could solve. You could. You could. And you solve for x. It looks like a pain in the ass though. 8 root 3 all squared and 16 squared and x. I don't know. Didn't we just mess with sine? Come on, dude. Let's mess with cosine. Let's go cosine 60. It's giving us the angle, and there's the adjacent, And there's the hypotenuse. So why wouldn't we set that sucker up? This is getting us ready so we can deal with some word problems. So we have cosine of 60 is equal to x over 16. Let's play that same game. Let's multiply both sides by 16 to get that hypotenuse the heck up out of there, out of that denominator, and leaving us with 16 times cosine of 60 degrees is equal to that x value, right? Because those 16's just canceled. Well, we can replace in for cosine of 60. Cosine of 60 is equal to 1/2. So what's 1/2 of 60? 16? Come on, bro. It's 8. So x is equal to 8 and y is equal to 8 root 3. There's a game. It's in your homework. I'll probably test you on it. You know how to play this game. It's how we solve for things. And you're going to struggle doing any of the word problems if you can't do this game. So, because they'll set you up like this, and that's how we kind of like, we go and get other values and things like that. So, I'll come back with a word problem one, and that's going to be it for 1.3. We'll move on to 1.4.